Alright everybody, welcome to Unit 2.04 Free Fall by me. So, why do we fall? It's probably because you're just clumsy. But the reason that we are attracted towards the earth is because of gravity. We fall because of gravity. How strong is gravity on Earth? Earth's gravity has an acceleration of 9.8 meters a second squared. This means that when we fall from a high building, we will accelerate at a rate of 9.8 meters a second squared. You do get slowed down by air resistance, however. Most people use 10 meters a second squared because it is accurate enough for most calculations. This guy's having a bad day. Alright, let's do an experiment. Does weight affect how fast some things fall? To do this experiment, we have to make sure that everything is fair. That means that we have to do the experiment in a vacuum, so that the air does not affect the fall. No, not that type of vacuum. This type of vacuum. It's just a sealed box, suck all the air of it, and you get yourself a vacuum chamber. What now? We then have to take the objects of different weight and put it in the vacuum chamber. Let's use a 10 kg weight and a feather to test this out. Put the objects in the vacuum. Alright, let's do this test. So, we then have to drop the weight and the feather at the same time to see which lands first. Here goes nothing. 3, 2, 1. Whoa! That was a bit mind-blowing, I know, but that's just the truth. The only reason the feather falls slower in normal conditions is because it gets slowed down by air. Otherwise, they would fall the same speed all the time. So, next, how do we measure gravity? We already know what the gravity here on Earth is, but what if we went on a different planet and we wanted to know exactly the gravity on that planet is? Simple. We use lasers. Duh. It looks a little something like this. Yeah, you got yourself a marble, 2 light sensors, 2 lasers, and a timer. How it works. When you drop the ball, it will hit the first laser, and this will start the timer. The ball will then hit the second laser. This will stop the timer. If the height of the fall is h, and the time taken is t, then gravity equals to 2h over t squared. It's a little confusing at first, but it's just the way it is. Now let's juggle some balls. Let's do a thought experiment. There is no air resistance and the gravity is 10 meters a second. A ball is thrown upwards at a velocity of 30 meters a second. It flies up to a point and it starts coming down again. Why? It's because of gravity. The ball slows down every second because of gravity. And once there is no upward force anymore, the ball will start to fall. A table of the ball's speed. Every second, it adds 10 meters a second because gravity is slowing down the ball. So it goes something like this. So at 0 seconds, the ball is thrown upwards. Therefore, the downwards velocity is negative 30 because it's moving 30 meters a second upwards. So then at 1 meters a second, you add 10 meters a second to 30. That will become negative 20. So it's now moving negative 20 meters a second upwards. So at 2 seconds, you now add 10 meters a second again, and it becomes negative 10 upwards force. And now at 3 seconds, it actually stops. It becomes 0 meters a second, and it stops for a moment, but it's almost unnoticeable. Anyways, at 4 seconds, you add 10 meters a second to 0 and it becomes 10 meters a second. So by now it's starting to hit downwards. So, and at 5 it's 20, at 6 it's 30. So basically it's just zoop, and that's how the ball is. Just goes up and down, up and down. Goes up, and then, yeah, you get the point. So that's about it. Okay, bye.